right. Welcome back from the break. Come on in from the outside, have a seat. We're starting back up in the two theaters. All right. Okay. Welcome. So we're going to get started here in this theater with Ram Iyengar, who's going to be presenting on ease from DevOps to MLOps, a case for ModelSpec and KitOps. And in the next theater to our left will be Dan Fernandez presenting on the Paranoid's Guide to Deploying Skynet's Interns. And welcome, Ram.
Thanks, Duffy. It's always a pleasure giving a talks at a Rejects event. I'm biased a little bit to say even more than the actual KubeCon itself, but I'll reserve my opinions for a forum that's not recorded. But thank you so much for being here and picking this talk over the other one. If it was me, I would be at the other talk too, but then again, thanks so much. The world is very excited whenever they hear the word models. For some reason, it used to mean something very different when I was younger, just as exciting, but something drastically different. And the world has not been, the world that I know hasn't been so excited for models for a long, long time. And people are really into the latest model, the most number of parameters, the cheapest tokens, what have you, and there's just so much going on. It's extremely hard for me to keep up. And there's a lot of things that we do speak about models and AI and all of this stuff, but there's also a lot of work that's going on in helping make this available in production for use as an organization in a formal way in the enterprise and things like that. And so that's really the most of what we're going to speak about here today. So I observed a tool in the wild and it caught my attention for a variety of reasons. And I just thought, I'll just create a talk out of it and share it with the rest of the folks and get more people to explore it. And I'm one of those people that look at the GitHub CNCF Sandbox repos when I'm free. I guess some of you are the same breed, considering that you're here to talk about cloud native on a fantastic weekend in Atlanta. So let's get started. And AI is hard to ignore these days, and it's everywhere. It's doing pretty much everything, I guess. And nobody I speak to who's an engineer worth their salt isn't vibe coding these days. So it's really everywhere. But once you speak to them about going beyond just the local use case or using local AI or just some of these publicly available models to do something serious and put it to use in an organization enterprise-wide and things like that, a lot of the truths come out about how difficult it is to get your data scientists to put everything in one place, how hard it is to hand off models to other people and things like that. So it's not the easiest and most convenient thing to get into production. And we've seen this game play out before, right? We've always identified some kind of technology that's come along, that's kind of changed what we do as an industry and the paths that we take as engineers. And then we coalesce around new paths and new ways to do the same things and put this on production and make it available organization-wide. We've discovered this whole way of describing it, whether it was platform engineering or whether it was some other way to do golden paths and things like that. So along the way, what we've discovered works extremely well from what was a very machine-centric world to what translated very well into VMs, to what became containers about 10 years ago, to what can now be learned from all these decades of using things that can be put in production and applying them to these AI models that require that kind of discipline and that kind of supporting structure and just a way to create a layer that really helps put this in production and make it more usable. So Along the way, we struggle with a few things. It's not the easiest thing to do. We discovered abstractions and how those can be a problem, and we've discovered that developer experience and improving developer experience is an extremely important thing. But you also have to deal with a lot of technical debt as you go along, and there's always, times when stuff gets implemented poorly and doesn't necessarily meet a lot of the standards you need, especially at scale. Where have we seen this before? Every single hype cycle. So every time something new comes along, there's a handful of engineers who report large amounts of productivity, for example, or they report things have really changed. And we've seen this with like Kubernetes, and even within the Kubernetes system, it was all about eBPF a few years ago. It was WASM before that, and it was Knative before that. And every single time something came along, everybody had to like jump on it and invest in it. And there's like a thing for that, right? So the plateau of productivity that follows, like the trough of disillusionment and things like that. And so I think that happens to everybody. So there's always somebody that discovers something cool. They have to, write about it. It has to rank on top in Hacker News, and then you have to try it out. And then suddenly there's people on the business side who are wearing suits who demand that, oh, why didn't we implement this yesterday? And then, you create a whole circus around it and you try your best to implement it and all that stuff. So, and what happens on the aftermath of all this? The aftermath is that there's always a two-part solution that you say, part of it is tools, part of it is technique, and then you have all of these dialogues that you create that are good for like posters but very hard to digest, where you say culture eats strategy for breakfast and things like that. And you make it extremely lucrative for people to try new things, but it's extremely hard to put that in production. And where have we seen this before? Like I said, every time there's been a shift in developer tooling, we've had to play this game over and over again. And right now, it's these data scientists who are creating these models, and then they give these models to the engineering team or this very thinly staffed operations team, I guess. And then, they just say, put this in production. I don't really know how. I don't care either. But this is the better model based on all of these improvements and all of these fine-tuning that we did. And so all over again, we're discovering this problem of, having to rediscover DevOps in the AI-driven and AI-run workplace. So you have a bunch of data scientists. They don't know squat about how to run something in production. I don't blame them. They shouldn't have to. But it's becoming extremely complex for the ops folks to take what they have and make it available, make it serviceable, and things like that within the organization. So how do you balance this world where AI ML is really everywhere, but you want to make it available for everybody to use as well? And so that's the point that introduced me to what is known as ModelSpec. So ModelPack and ModelSpec, these are like a family of projects within the CNCF ecosystem. There is a specification that's available. It's a sandbox project. Everybody can check it out. They just released this website. If you're too lazy to type the words ModelPack in your browser, feel free to scan the QR code. And I think this website is like 10 hours old or something like that. Talk about event-driven development in a totally different way, right? So they just released it in time for KubeCon, but it's a CNCF Sandbox project, like I've mentioned 5 times already. You're welcome to come contribute, have discussions. There's a lot going on in terms of trying to define the basic structure and framework of what it is like when you bring AI into the cloud native world and really try to benefit from both like the Kubernetes and the AI part of things. So ModelPack defines the structure of using OCI artifacts for storing your models and storing everything that's related to a model. And there's a twofold reason why the community decided to do this. The first is OCI artifacts are already content addressable. What that means is you can address individual layers or pieces within an OCI artifact, and as long as you group a related number of items within the artifact, you can get to them individually, or you can get to them as a whole. Now, we don't advocate deploying a model and the transformer architecture and the data sets all as a container, because that would be somewhat stupid. But if you wanted to deploy just the model, for example, or if you want to hold all of the data and the weights and all of the parameters related to said model in one place, as opposed to keeping them, wherever everybody else likes it, it's a fantastic way to just have that kind of physical and logical grouping in terms of, okay, everything related to this model is available here. Version 1.5 of that is available. Version 1.6 of that is available, so on and so forth. So it's a very convenient way to make use of OCI artifacts to preserve the model and everything related to it and the versioning. And the other thing is the immutable half of it, which is that it's very easy to go from that point to pulling that image and just deploying whatever you need into your container runtimes or your container orchestration with Kubernetes, what have you. So I can talk about this for another 20 minutes if necessary, but let's take a look at a demo. Let's see how it actually works, if it actually works, and we can be a little more convinced. So I have about 10 very different things that I'm trying to accomplish here today. Let's start with one. So what you can see here is it's got like this model I pulled from Hugging Face. It's got like a bunch of other related bits to it. And the first step that you take is you create what is known as a Kit file. So I'm just going to run this demo very quickly, and this is going to demonstrate what Kit init can do. Kit is a CLI for KitOps, which is the tool that implements ModelSpec, and it creates model packs. Okay, it can be a few pieces to remember, but again, it's going to be totally worth it, I guess. So for this model and this related set of artifacts that are around it, we're going to create what is known as a model kit. So I'm going to give it a name. It's going to ask for some descriptions and things like that. And for everybody who's written commit messages in the past, we know we don't like to write any of that in a way that makes sense. And obviously I'm going to, it requires an author name. And so what it generates is a meta file that then logically allows you to create like a bunch of different things where it'll tell you, it'll identify that there's a model in the path that you've given, and there's other things around the model that relate to it, but they're not the model itself. And there's further things in the same space that are sort of, packaged or likely to be packaged together, or you're going to benefit from packaging them all together. So let's see something that's slightly larger. So in this example, I have a lot more artifacts, and I can do the exact same thing. So if I say kit init on this path, it will generate the same kind of thing. And then you can describe this. And then it will give you like a much bigger thing where it doesn't matter what the nature of the contents are that are related to your model and things like that. You can still have Kit create that meta file that captures all of this information. Now, what if you were tasked only with creating something like training data? So there is support for that as well. So in this example, there's just like a couple of CSV files, which is training data, and I can do the same kit init operation here, and it will say pick up only that stuff. So it will create a model kit that has only training data. So you don't have models in this. So if you compare it with the ones that we generated previously, you had a lot of other pieces. But in this case, you can just do data, and you can use this model kit to hand off data from one team to another. So it will help you version data sets. And there's a lot of interesting use cases that you can build on top of this. We'll get to that in just a bit. But also, can you do deployments, for example? So I have a bunch of YAML, obviously. Thanks, Inji. If you haven't met Inji before, he created the YAML spec, so I highly recommend shaking hands with him at any KubeCon event. But I'll have to admit, Inji, I don't like writing YAML that much. So what I'm going to do is, put on my vibe coding hat for a bit. And so I have this MCP cluster. MCP connected to my Kubernetes cluster, and it basically has access. And I'm going to say, can you deploy a particular model that's available on a particular registry and use like a Llama CPP as the container type for it? So let's see if, fingers crossed, Claude is able to pick this up and do it. It did it at 1 a.m. this morning when I was jet lagged, but yeah, you never know. So yeah, so it's it's going to do the deployment onto my local cluster. So if I open it up, it's picked up that model from the publicly available registry, like I asked it to, and then it's going to deploy it to my Kubernetes cluster without without breaking the mic, but also like without writing any YAML for that. So KitOps allows you to create these artifacts, okay? And it allows you to do deployments that are quite sophisticated like that. Because I was able to package this and then push this to a container registry, it was possible for me to then make use of MCP and get a lot of automation done. So one of the big use cases around this entire thing is the ability to automate a lot of the pieces around the operations side of making machine learning possible. So let's see what else we can do. So I'm not entirely sure what this demo is, but let's run it. Yeah, so kit pull is a way to pull one of these artifacts. So in this case, it's just pulling a model that I have on this publicly available registry. For those who are unfamiliar, Jozu is a publicly available registry that promotes a lot of the model kit and the ModelSpec stuff as a company. And so I'm just making use of that. And what I'm doing after pulling that model is unpacking all of the stuff that's in the model kit. So if I open this up, you can find that a lot of the stuff that I'm trying to, that I pulled is available in the public registry, and that can be a standardized way for a lot of people to pull that and make use of it. So let's see what else we can do. Yeah, so I think this one does the opposite. So yeah, this one is kit pack. So it will create a model kit and then package it as a container or an OCI artifact. So you can see that it will create all of the layers, and then I'm going to push this to my GitHub container registry, which is different from what I was using before. So any container registry that you have can support all of the automation workflows that the whole MLOps pipeline requires. So it doesn't require any specialized registry, but it ties very well into a lot of the container-based ops that you're probably doing right now. And I'm going to cut this demo short because it's going to upload the whole internet, obviously. Yeah, so that's a lot of the commands and things that you can do. And let's quickly sort of revise. So we saw pull, which is the ability for it to get some stuff from an OCI registry and then put it on a container runtime of choice. It'll contain all of the different pieces, but will only deploy the model if required. Push does quite the opposite. It takes any repo that you have, it'll package it into an artifact and then put it on the OCI registry. You can do a kit list. which will list all of the things locally. So these are all the different model kits that I have, along with sizes and the SHA and all of that stuff. Kit init is the command that we saw to create like the basic boilerplate and the scaffolding that you need for creating model kits. Inspect is another useful command. It will allow you to inspect a model kit, whether it's remote or whether it's local. Pack is the command that allows you to package it into a model kit. Unpack is the opposite. And you can also do the last bit of the life cycle, which is like remove model kits if you don't want them. Login is for authenticating with a container registry. Right now it supports all of the popular container registries available as long as you have access. And where have we seen this before? If you're thinking Docker, then all of this is, they say imitation is like the finest way to do flattery. And I think Docker really revolutionized developer experience about 10 years ago. And inspiring from these, I wanted to say copied or plagiarized or stuff like that. I don't want to be mean to the KitOps community. Inspired by all of that success that Docker saw and how entrenched we are as ops folks in that world, I think it's safe to build a paradigm that mimics it and helps people understand things in sort of the same way. You could ask, nice demo, nice theory, but are there real use cases for this? I think there are. And one of the first ones I wanted to highlight was model handoff. And like I hinted before, there's data scientists that are preparing these models. There's engineers who are putting them to use in applications and within applications. And then there's the ops folks that have to really operationalize these models in production so that what the engineers envision and imagine will work have to actually work. And so for you to be able to communicate to all of these people and hand these different pieces off to from team to team is extremely hard, and there's no clear place. As a community, we've invested a lot in infrastructure as code over the years, and that's because we wanted to make that life easier. And so this is a very similar effort where we're just creating packaging so that it's all not, there's no sprawl. It doesn't break, and you don't forget things, and you don't lose track of things. And what happens when that one data scientist who's on your team decides to quit and join another company, for example? So there's a lot of things that you can prevent, like truck factor and other things among the people that are really trying to productionalize this. The other thing is very general ops style. And what I mean by that is there's so many things that go into putting this model on production that cannot necessarily be automated the way we work on it right now. There's a lot of ad hoc scripting. There's a lot of bandages and things like that where it's not a repeatable, easy process that people have. And so this is a way to really compartmentalize a lot of that effort and say, do these finite number of steps repeatably and easily in order to productionalize what you need for pushing that whole MLOps agenda forward. And finally, there's a lot of awareness about supply chain security these days. And one of the use cases that model kits support is the addition of signatures. So in one of the repos, I had signatures. Yeah, so you can use cosign. If you're already using cosign or Sigstore to sign your artifacts, you can use the same workflow to sign a model kit artifact and communicate that, because it's just a simple OCI layer. So there's so many wonderful use cases that this entire way supports. And we don't have to necessarily sleep on all of the stuff that's going on before some security incident rudely wakes us up and says, your entire MLOps strategy needs work. So there should be a GIF of somebody blowing up here. But anyhow, that was my talk. Hopefully you had something interesting to take away from this. I highly recommend joining the community, being part of it. We really could use the extra hands. But thanks so much for having me at Rejects, and thank you so much for being a patient audience today.
Any questions? All right. Thank you so much. Next up, we have Matthew talking about make your developer pains go away with the right level of abstraction for your platform. Artem and Matthew, if you haven't already, please go up there and grab a mic if you want one. In the next hall over, we have how to use an AI assistant with your monitoring system by Matthias.